Welcome to another episode of Tech Unhinged, where tech gets human. Joining us today is Arturas Tutkas, engineering manager and data platform lead at KAYAK. With over 15 years in software and data engineering, Arturas specializes in cloud migration, scalable data platforms, and integrating advanced technologies like Trino, Spark, Kubernetes, and machine learning ops. We are excited to have you on the show today, Arturas.
Rabia, thank you for having me.
Before we get technical, I was curious, what got you into the world of data in the first place? Was there a this is it moment for you?
Yes, I think so. As you mentioned, I started my career in the software. Well, now it's more than 20 years ago. But from the day one, I think I found the databases somewhat magical and ability to store the data and basically be able to pull the stuff. I still remember my first query, which was like my SQL query, with a bunch of like my SQL injections in that, which is you never run on production. But fast forward, I always was working around data, not even realizing that things like, like data is a thing to do at all until around, I guess, like 2015, where my title actually became a data engineer. And that was like very clear. The moment where it was like, this is it, I think this is where I realized that you can provide so much value to the business from the data, like pulling data and then sort of like realizing that there is much more around the field that you initially thought.
Well, Arturas, you've gone from coding in PHP and Java to helping shape how entire data systems work. If you had to describe that journey in one sentence, how would you sum it up?
Crazy. But yeah, but like if to go in one word, so as I mentioned, right? So there was a stage in my life when I was working in the accountant company and we were creating accountant app, which was built on top of the database. It's just sort of like was this old times where you have a database, but then you sort of like has like a forms, and it was like all accountant applications just built on that. In the reality, it's just like I didn't really realize that, like the structured data sets actually changed the way how I'm thinking. Like even right now, I'm realizing that I'm required to have a structure in my life. Otherwise, I feel unsafe. And this is just like reality. I think what I do find, the experience from like PHP, Java, and all of software engineering is very helpful because the data world doesn't really follows majority of the software engineering principles or patterns. And the reason for that, I actually had a conversation with my friend. The reason why you don't see many patterns in data engineering now in the in the data science these days, or like LLMs, is because the value which the data engineers back then and even now, and the value that the data sciences brings now is way, way overweights the value which you get from, like making things correct and optimal. Like no one really cares if your code optimal or not optimal when your change will, like earn thousands of or millions of dollars. So I think the important piece here is that we have these cycles, and this is what I actually seeing. And I know that I'm going way off with your question. I'm sorry about that. It's just like, let me just finish that. So what I want to say is just like, I do see a cycles which is repeating over and over again. So me being in the software engineer helped me a ton to sort of like learn the principles. Then I was able to get into wild west of the data engineering and slowly apply those principles in there. That's what made me successful. Now I see a lot of like machine learning and, like the data science things, which is now again is the wild west. So I'm hoping to be able to be a part of that and bring some structure to it and make it more successful as well.
For those who are listening, what does data engineering actually mean today in 2025?
Oh yeah, that's the world is changing. It's not only changing for the data engineering, it's changing, I think, for everyone who works in the computer science or any, adjusted field. I mean, it's sort of like, I don't know, it's AI is not a new thing. We always had AI, like if you look back, how to say it is that we had, like sort of like machine learning, how long, like 50 years ago, like initial starts of sort of like doing stuff like that. I don't really, like not really a big expert on those things. Like now these days, AI is a little bit like overused phrase. Let's call for the things what they are. So today, if like the ChatGPT and OpenAI showed us something, they show that if you take a huge amount of data and you spend a ton of money, you actually can train this huge, like large language model, and then you apply a bunch of transformance. That's what the T stands for, as I understand correctly. You actually can get something very useful. I remember a couple of years ago, the first time I tried ChatGPT 3, I believe, I was like, that's stupid, and then suddenly it was like, oh my god. God, what's that? And then a little bit later, I did a little bit more research. I was like, oh shit, that's amazing. And then I remember having a conversation with my coworkers. They're like, look, like this is amazing. And I showed them, and they're like, oh, you stupid. That's nothing. That's like, look how bad it is. I was like, it doesn't matter how bad it is. You need to look how great it is of what it can do. And basically, like I think now what I'm hearing, which I'm not really happy about, is sort of like it's this push for like, hey, like the AI will replace everyone. Maybe it will, maybe it won't. I don't know. I mean, what I do know for a fact is that the tools, which is powered by the AI, is actually can improve your productivity so fast. Like I personally, for my personal projects back at home, I bought like one of the IDEs, which is powered by the AI. I use that as an advanced autocompleter. It is amazing. I remember back in the day, 20 years ago, people would be like, oh, we write Java code on the notepad and then we compile that and we're so great. And you using IDE, you stupid, you don't know how to write Java code. And I was like, yeah, but like, I don't need to learn everything from mine. I just want to be productive. So this is the current world of the data engineering, right? It's the same thing. Like many companies are pushing for tools which will change everything and like fully automation. But I think what we actually should be looking for is a tools which is as tools improves our performance, and we can actually deliver much more than we ever had before. And this is what, so saying that, what is very important to note is that you as a data engineer now need to more understand the principles of how the things works in the background. You need more to understand the SQL and the Python than Snowflake or the Databricks, because the Snowflake and the Databricks is a layer on top basics, which, you can do. So if you now use OpenAI or, like any other tool, you actually can very quickly learn Databricks without learning Databricks. You can just say like, hey, I want to do this thing, and it will do. If you don't know what you need to do or how you need to do, you're screwed. Even with these great tools, like at least for now, like none of those tools will be able you to build a pipeline if you don't know how the pipeline should be built. So as you see, I may be a little bit more, like old-fashioned. I still believe the power in humans and our judgment to decide what makes sense and what doesn't. And this is what I stand behind.
From your decades of experience, Arturas, what's one of the biggest misconception people have, even within tech, about data platforms or pipelines?
Right. So I think today, if you speak with a lot of like AI experts or, or just experts in general, everybody thinks of this data platform as a magical box where you just throw any data and then you just run something and you're getting the data out. I mean, I remember, I hope this will answer the question, but I think this is still true. So I remember once I had a conversation with my old friend, and he just joined a new company and he brought their lead of data analytics or lead of data science. I don't remember. That was like 5-6 years ago. And he's basically coming to me and saying like, look, we have a problem. We have this person who will be changing, will be lead of data analytics. And now he wants something from me and I don't understand what he wants. And I'm speaking with this person, and this person said like, look, back at the company X, we have this data warehouse to which I will be able to connect, and I was able to run these queries, and I was able to pull all of these insights. And here we have nothing. And I'm looking back into it. It's like, hey man, you don't have any data engineers to actually build all of that infrastructure for this person to do the job. And this is what I think is also the situation. Some companies might go and hire, the data scientists on AI experts, but if they don't have underlying infrastructure or the pipeline available there, it's just wasting of resources on the people who will never deliver that. And it's nothing against any of those people. It's just not their job. Their job is to rely on the infrastructure, which it is. So this is what I think I want to say. It's just like when you're thinking of any data projects, you need to make sure that you have the underlying data infrastructure available, or data platform or pipeline. So any of these keywords, should be, is there anyone who understands how the data flows? And that's, I think, sort of like it's the biggest thing in my head is that people very often think that they can buy a data scientist, a data analyst, or they can buy a tool and that will fix the problem, which is not really the case. You still need to have this understanding of how the data need to flow, which database is good for which workloads, and that type of things.
Arturas, when people talk about scaling AI, most of the focus is on models and outputs, right? What part of the data pipeline do you think is most dangerously overlooked in that entire time?
I remember having seeing this meme, which basically describes, like the data quality and then sort of like the output. And there is this, like common phrase, like bad data in, bad data out, and it doesn't matter what you do. And I think one word to summarize all of that is the data quality. Now, I had a conversation with a person who started his career when my mom was like 10 years old or something like that. So
Okay.
yes, he is, he is elderly person, and we had lunch, and I just really enjoyed talking to him. So he started his career very early, 70s or something like that. I haven't been born back then. And we would talk about the data, and he was like saying, like one of the first projects he worked was with the US Postal Service, where they needed to recognize the handwritten addresses and basically, like convert that into something so they would know where the mail should be sent. And they sort of like did all of that pretty well. What he then sort of like did was sort of like scanning a certain documents, not even scanning, like, like he was saying, like they would be the system, which I don't even know the name and how it works, where they would enter, like the customer's name and the address, and then you sort of need to match which customer it is. And he explained me a very simple example. He said, like, look, think about this way. You have two documents. In one, it's written IBM with the spaces between, and in another, it's written IBM without the spaces between. You as a human understand that's the same company. Machine will never understand that that's the same record. For machine, that's completely different, because machine interprets, it doesn't have this knowledge which we do. And the biggest problem we encountering, and why sort of like the data quality is important, is not because of the machines is stupid, it's because of us. It's because we are not predeterministic. We always change our minds how we describe things. We always change our mind how we do things. And what's happening is that, like the machine is expecting one result, and then like, well, crazy human changed his mind again. Like, I don't know to which customer should I attach that. And this is what is the main problem. And this is the main thing which is overlooked right now. Like, why do you think we have this hallucination in there? And the reason is because the data quality is not meant for these things. So we run and we sort of like, and that's what sort of like credits to him. He was talking about, I will tell you this way. I don't understand half of what he's saying, but he said like one of the things to make LLMs great is the semantic layer. And I was like, what's that? It's basically like you need to have a layer which would not only be used as ability to learn to predict tokens one after another, but also add a knowledge around which tokens is associated with which. So actually you would improve your context. So you would not, sort of like add stuff which is, like crazy or not realistic. And he gave some crazy examples in there. It's just like, like that sort of thing. So speaking of, like the data quality, another example which I really want to add. So I don't know if you know or not. So our organization recently launched KAYAK AI. And I sort of like spoke with, like engineers back then. And one of the things was like, okay, so the data quality, how can we make sure, that the user, like when it's writing, it's accurate? And this is something what we, like back at KAYAK also understand as an issue. And what we basically trying to do is like, like we pulling from, from our partners' websites, all the information, and we sort of like trust on the quality of that data, which we bring, and then we provide it for the user. However, that's the problem. If the partner's data is inaccurate, the AI model cannot really anyway, like validate that's the case. And that comes back to the same principle, is that at the end of the day is we who screwing up the machines to have an easy ride by our constantly changing our mind, not having like the data accurate or in the form which would be useful for machines. And that is what, in my opinion, is the most overlooked thing in all the AI infrastructure, is the data quality and sort of like how do you deliver this data.
That again makes sort of a lot of sense. But also, Arturas, you've seen, decisions like schema enforcement, right? Skipping it or making it a part of something can impact flexibility on a massive scale. So in a world where AI might start generating pipelines, and we are not actually far away from that, where should we draw the line between structure and speed?
Yeah, so I like what you said, like the AI can generate a pipeline. So I'll just reflect a little bit back, as you see, like a little bit hyped about our KAYAK AI stuff. So if you ever use it, think of this way, it doesn't matter how great it is, would you allowing this chat model to book you a trip without you validating that that's what you want?
At a certain point, I might, with how fast
Right,
it's
today.
going. Yeah.
Right. But like today, like, well, I don't know, like I myself, even in the future, I would want to ask with my wife, like, hey, do you think that is the right thing? Right. Now, to achieve the goal where we could be like, oh, I fully trust, just book the trip, we need to provide more context. And that's, like possible in the future. I think you still need to have the user, like this is the thing, right? So with all of the tooling, okay, so let's sort of like go this way. So when we're talking about the, like the AI and all this stuff around it, when we're talking about the tooling powered by AI or powered by the LLM models or the agents or everything like that, it's actually very clear to understand where is the responsibility for the committed code, where is the responsibility for the committed, like pipeline. It's on the developer who uses the tools to improve the performance of his work, but he, like delivers the responsibility of that what he is committed is actually accurate and true. Now, if we're going into the world where the AI is able to create everything, like who is taking the responsibility for truth of what is done? You could say like, well, if the AI doing that, then AI is responsible. I mean, but like, I don't know, like I see the world where this is possible because you build, like the pipeline and then you have a bunch of checks to make sure that you're not like losing money or stuff like that. But can you ever imagine the world where there is no human at all interacting and validating what is deployed and making sure how to overcome these things? I mean, maybe the future is there. Right now, I don't think that's is the thing. And the most important part is if you have a company, I think you still want to be responsible for what you're delivering, and you want to have someone to be accountable and knowledgeable about the things it is delivering. Like I like the vibe coding memes and stuff around. I think that's a great idea. It's just like what you find is that, AWS codes committed in the GitHub. And now, the buckets is open. So you could say like, well, I didn't do that. AI did.
Yeah.
So like, should we fire AI now? This is the thing. So I don't know what the future will be. I mean, I think that I see much more value from the companies which concentrates in providing the tools to improve the person's speed executing the task, obfuscating the manual, not interesting labor, allowing person to use his mind to come up with more greater ideas to do what he wasn't able to do because he didn't have the technical skill, but he always had the imagination. Then rather, like take that all away and try to sort of like push that to AI. Eventually AI will be just limitless because of the imagination, lack of the imagination. Well, again, maybe the future will be different. I mean, for now, if we're talking of the world where I can use AI, which can enhance my performance, I love it. If we talk about AI, which basically eats all my fun from my work, and then I need to do something unfun, then I don't like that future.
Yeah, because I've seen a lot of videos rolling out generated by AI. If you've
Oh,
seen
yeah.
certain results out there, it is close to impossible to figure out if it's a real video or an AI generated video, or it takes an eye for detail to actually pick that detail up. With the fires in the Arizona forest, right, and things happening around in the world, there are certain fake videos that are out there with the most likes and the most engagement.
Yes. What I think is very, like interesting or useful for the future is that like even with this fake videos, what you are enabling is people who never had means to create something, like nice, now can do that by just using their imagination. And they can use these models to say like, hey, build me this new cool stuff which I never was able to build. And I think that's good. At the same time, you will have a lot of people using that and abusing that for the bad things. But that's just like, I guess, how the world is.
Well, Arturas, while going through your career highlights, I did see that you've made bold decisions to, move away from Snowflake, a choice that many teams might hesitate to make. What triggered that decision for you and your team, if you can give our listeners some context?
So first of all, what worked for us not necessarily would work for any other, like any other organization. So So I think this is, again, getting back to what we, like spoke earlier, is the data engineering world is changing in the way that we have so many tools to be so efficient and to do the thing. So what we need to concentrate on is to making the right decisions and basically figure out what makes sense for us. So this is what was not making sense for us with, with this concept of the Snowflake. But at the end of the day, it's sort of like, like the tools which we use is an opinion on how organizations should operate. Like sometimes opinions are not good for them. And that's the thing, right? Like we sort of like had our own ideas of how we want to operate, and we just realized that that tool doesn't work for us. And we found a different tool, which that's about it.
Well, Arturas, for our listeners, is it usually, the cost, the performance issues, or something deeper about how, the data systems need to evolve? How would you put it together?
So I think this is something deeper, right? It's sort of like it's, as I mentioned, like if the tool doesn't solve you a problem and just causes you a headache, I mean, what's the point of using the tool? Maybe you should change that, right? I think the good example is you can always use, like a pickaxe to put the nail down, but the hammer is much better at doing that job. I mean, sledgehammer is a little bit too overkill for doing that job. So, and I think this is what is, again, I will repeat myself, like what is important for the data engineers in the future and now is understanding the difference between what each tool is doing and what type of the problem you're trying to solve and which tool is actually will be the one of solving this problem. What additionally you need to understand is that, well, the deeper thing, which I mentioned, this is something deeper. It's actually, I just realized it's people to whom you worked with. Like the people who uses the tools which you brought to organization or the tools which is like, hey, from now on, we'll use that. The people is saying if they want to use that or not. Like in our case, well, not in our case, like in general, like I see that there is two types of organizations, the data organizations. There is a data organization which would write applications. So it would be like PySpark or Spark group. So that's the Databricks for you. Or you would see an organization which is very for writing SQL and they want to do everything in the SQL. And that would be sort of like Snowflake for you if you want like two spectrums. So now if you're coming to an organization which all the time was writing SQL and say like, hey, from now on, we'll be doing Databricks and we'll doing the Spark because it's much more cost effective. Yes, maybe the technology might be more cost effective, but the people will be completely against that and they will not have knowledge of running those things. And you basically will just completely screwing up. And that's the thing, what it comes to. It's just like you need to understand your organization, you understand what your people needs to have, and then the tools needs to solve a certain problem. You shouldn't bring the tool first and then figure out what problem it can solve. You should sort of like go the opposite way. If I just may, I remember I was at this presentation and one presenter from the big company, he was like, hey, we have this great, amazing new technology. Like we can put the CPUs like free layers. We can make them sort of like, like the 3D CPU. It can have a huge amount of memory. And then like, okay. So what can we do with that? And the phrase was like, and if you have some problem where you think this could help, like tell us and we will be more than interested to provide you this hardware to test that. And it was like, so this is an example where we have a hardware built for something where the problem doesn't exist. And then you going and saying like, hey, we have this nice tool. Can we figure out what problem with that? Bunkers. It's first should be a problem and then the tool's fixing the problem, not the way around.
The story really doesn't end there. That's where Trino comes in. And I'm going to
Yes.
talk a bit about it. Why? Is because, you mentioned somewhere that it wasn't just, a tool, but a bridge, right?
Yes.
So there was a lot of analysis that went down that lane for that particular tool. So, for our folks who may not know about it, how would you explain, what that tool is and how did it click for your team while the previous one did not?
Yeah. So I think, like I don't want to go too much into details, but I think the main important thing here is the Trino is open source. When it's an open source, you actually control everything. It's both, like I don't know the English word for that. So it's basically both, the curse and the opposite of what the curse is.
Okay.
So
a blessing in disguise.
Yes, exactly. So it's basically both the blessing and the curse, because it's a blessing because you know everything, how it works. There is no proprietary technology in there. You're able to see all the metrics. You're able to see how the CPU is working. And it's so with the open source, but also it's basically, it's a curse because like now if you need to optimize for something, you're basically all alone or the community, and it's very hard to achieve something like that. So Trino is something like that. It's a blessing and a curse, is that it's amazing in the way that you see everything what is happening, but also it's like very hard to do the things right? So you need to have sort of like a talent available to be able to do that. But if you have the talent, you can go and do that. Now, I think if you are a small organization which doesn't have talent, or nor they should have talent, if it's like a small data organization, then don't even look at Trino. Go with something already pre-built, Snowflake or Databricks, whatever, doesn't matter, and you will be way better off. Trino is great because our data organization is much bigger. And when I'm talking about the data organization, I'm talking of the size of the data we're dealing with, not the size of the people, right? So we needed to be able to see where we're spending all our resources in. And that's sort of what a Trino allows us to do. Like not only Trino, like any open source would allow us to do, where the Snowflake is able to solve a problem in a certain way, but then if the way how they're solving problem doesn't fit us, then it's sort of like wasn't the case. Now, to your question, what is Trino? So Trino is the virtual warehouse. So what does it mean, virtual warehouse? Well, aka query engine. What does it mean, query engine? If you think of database, you have a data storage. So on the disk, there is a data storage. Then you have the CPU and RAM, where parts of the data is pulled from the storage into an active memory, into active CPU, and the calculations is done, and then the result is spitted up. And this is all happening in one computer. So now with the rise of the, Snowflake, Databricks, all of the Hive, I think Hive was the first one who started that. The idea was like, well, can we scale, like the storage independently on the compute? And what they figure out is that, well, we actually can, and this is where the S3 was very helpful. So basically, like what the query engines came in with, so like, hey, we don't have any storage of our own. We rely on some other storage. What we do have is the CPU and RAM, and you just load whatever data you want, and then we do the calculations in memory, and we sort of like give the results. So this is what the Trino is. Trino is a query engine first, where it sort of like utilizes that. Additionally, what the Trino engine is, so what the Trino guys thought about that, and that was like back at the Facebook, was like, well, it's already doesn't really rely on the storage. Can we use any other tool or any other database as a storage as well? And the answer was yes. So now the Trino allows you to query data from your data lake in S3, query data in Snowflake, query data in your MySQL, bring all of that together in memory close to CPU, run the joins, run the aggregations, and deliver the data. So this is basically what the Trino is. It's basically say like, hey, because we don't have a storage, because we open source, we actually allow you to use any technology out there for your storage or for your compute, and we just bring things together, and that just makes life so much more easier.
Yeah, no, I think that was very nicely put for our listeners, and thank you for this thorough answer. Well, Arturas, while going through your career timeline and some of the work that you've put out there, I found that, you try to put a philosophical angle, to the tech side of the work. And you once said that every tool has an opinion about how data should flow. Well, would you like telling us that what does it mean in practice, and how has it shaped the way you evaluate new technologies?
I think I even this time I use that. I just, this is what it is. Like it's opinion. And early in my career, I start seeing that with initial frameworks, right? So for example, in the software engineering, we have a frameworks. JavaScript has like a bunch of frameworks. All the frameworks is relying on the base technology, and they are just opinion how this base technology is used to perform one another, like example. Now, so imagine, for example, like for the going and evaluating the different technologies is, let's put it this way, like let's put like a very simple example. Like you have a car, right? Car is a very universal thing for everyone.
Mm-hmm.
Now, however, if you in K or in US or in some other countries, there is a different where the driving wheel is, right? Like where you control the car. Is it on the left side or is it on the right side? And now, because of that, the infrastructure of the roads is also different. The rules of the driving license when you pass is also different. Like you have, like, is it like left hand or is it right hand? Like, do you turn this way or this way? It's all depends where the wheel is, right? Or the control of the car. And that's the thing. Like, if you just buy any car without understanding where the car will be driving, you can be in very big trouble. And that is with everything. If you first just jump in on the just jump in and just like, hey, we'll buy this tool because it's amazing, you might be in big trouble. The reality is that in the computer science, none of the applications is able to change how the physics works. And why I'm talking about that, because at the end of the day, this is just like, like electrical impulses back in the CPU going and doing all of the calculations. There is a, like the speed, how fast they can do. If someone comes in and say like, hey, this new software is now 10 times faster, can't be 10 times faster by just being 10 times faster. It needs to basically make some corners or need to make some things where they say like, well, we'll prioritize this, but in the face of that. So it's always a balancing act. And that is for all the technologists as well. So this is why it's so important is to understand the problem which you're trying to solve, understanding how the tool which you're looking for is trying to solve this problem, and then trying to figure out what is, what is the side effects which you will get by using this tool. And this is usually how we, validate the things or evaluating the new technologies and how to use that.
Data platforms are the engine rooms behind AI. And, as you have built one from the scratch and have overlooked many, do you buy this idea, or do you think that we are just overselling the concept of it?
So I think it's, again, will depend from the point of view looking at. If you're looking into building a new LLM model, building new AI model, building anything new, basically building a model, you need to rely on the massive, not massive, not necessary. Like you can use your laptop and that's usually enough to start, somewhere. But you need to rely on eventually on the data infrastructure or your data to be able to train the models. And that's usually what it is, just like tons of training data to, increase the value of your model, LLM model that included. If you're using any of that, if you're using any of the build models, you don't need any data infrastructure whatsoever. I mean, as you said yourself, like you can just write a prompt and that will generate you a video, right? So for this to happen, you need a lot of data to build a model. The moment when the model is done, you don't need any data infrastructure whatsoever. So again, it depends, at which angle you are. Like if your job is to build a new model, yes, that is important. It's not necessarily might be called data platform, but you will need to be able to have some pipelines at least to be able to feed into. But when it comes to, usage of that, like, no, you don't need any of that. Like even if you're building your business relying on someone else's model, you don't need any data infrastructure at all, unless you want to do your own analytics afterwards.
Let's just go to 5 years ahead of us. It's like you've got 15 years of good experience. And what if 5 years from now or 10 years from now, AI is able to generate pipelines, deploy it, do everything by itself? What do you think would happen to the role of data engineers? Would we just be the curators, overseers, or just go obsolete? What do you think?
Yeah, so I think when was the OpenAI released the ChatGPT? That's what I believe was already like 2 years ago, right?
Yep.
So sort of like when it's sort of like hit the news and like we were like, oh my God. Back then, like OpenAI said in the next 2 to 3 years, we'll have AG, right? Like the AGI, I think that's the term, right? Like we'll have like the general intelligence, artificial general intelligence. And then they changed their mind. What does it mean to have artificial general intelligence? And then they changed their mind once again. I think it's actually a very big problem to solve. First of all, LLM model, it's like, and it's no, limiting to anything. It's a great technology, don't get me wrong, but like just you need to understand the following thing. So your phone, right? And when you're typing something, it's basically suggests the next word for you to type, right? So that is LLM in your phone. That's what it is. That's the source of the OpenAI. That's the source of the ChatGPT. It's a little bit more expanded. It's sort of like generating, like a next token in your mind. However, if you think about the human and how we talk, how we communicate, we don't know which next word will be thrown out of our mouth. Like it's just somehow does, right? Like it just like gets. So you can think of that. It's also like we are token generators, like we're word generators, which we're spitting out. And then if I'm talking plausible enough, you will believe that I'm saying truth, but I be full of shit, like bullshit and like nothing like that. Important thing here is the trust in the unit which is spitting these words and the trust, right? And unless we have this trust, we always will need to oversee that. Now, what the LLM models are great, really, really great, is translating from human language into the machine language and then reverse. And this is what we see with all the agents bumping up, because this is like a very useful thing where I could say like, hey, I want to generate the video for, I don't know, kid on the skateboard. Then this LLM model will hit a certain agent, which is like, okay, now we need to generate video, and that's all the parameters which you need to do, and this is all the other parameters which you need to do, and this is all the extra information. You just push that into the agent, and the agent will do this own thing, and we'll see, we'll spit the results, right? So that's the thing. Like, it's amazing when you're looking into that, but if you will take away the agent out, the LLM by its own will not be able to do that. So for example, at the same time, LLM by itself will not be able to drive the car. Maybe LLM using an agent will be able to write another agent, will be able to drive the self car itself. I think if the artificial general intelligence would be easy, we would already had it. We're talking about that for definitely 50 years. It's a hard problem to solve, I think. I have no idea. Yeah, so getting back to your question, I think in the next 5 years, finger crossed, nothing changes, because otherwise all of us will be out of the work. Well, with the exception of you, because, that's a different story. However, what I will believe is that there will be more tools coming out which will change the way how we work, which will require for us to better understanding underlying principles, and just will have like much, nicer IDs, autocompleters, or like other tools. And we'll need to be the ones who oversee, as you see, what the LLM models produces. So we would be take the responsibility of pushing this code, shipping the product, and we know what the product is actually doing, and it does what we asked it to do, and not trust, blindly.
Arturas, given that if you had the power, and assuming that, AI has already sort of taken over, if you had the power, what part of, data platforms or generating pipelines would you never just give away to the AI, or would never sort of want it to be automated in any way? If you had a control over it, what would you choose?
So let's assuming that it can do anything and it's actually very, very good, right? So then I assume it's dealing with people. No, I'm joking, of course.
That's a good one.
Yeah, I think what is there is, but that's also the true as well. So there is two things which is very important. So the first thing is cleaning the data from what we messed up into the data structures and the sort of like the principles, which would make, the data as it should be. And then dealing with all the requests which you're getting, from any analyst, like, what about this? Or what about that? What about this? What about that? I mean, it takes so much time. It's such annoying work to have. I mean, I don't do that much these days, but like back in the day, it's just like, come on, like, this is the dashboard, just go and check there. But like, what about that part? Is like, you need to write this a query, and it's like what the data says, like, oh, what does the data says? And like, oh, and it's just like that. So this is, I think, where the AI would be beneficial, where you could say like, okay, like the AI can give you an answer from the data which is provided. The problem with that, again, it's if the AI is great. The problem with that today, we actually try to do something like that. The problem with that today is that you can lie to AI and you can actually get the data which you want. And then you can change the narrative about the data and basically tell any story you want. And then you're having like a person coming to you and say like, hey, look, I checked with the AI. This is the number it's provided to me. Explain that to me. And then you're like, what? And that's basically the scary part, but it will be fun.
If we look ahead, what's one development in data infrastructure that truly excites you? Where do you think the next big shifts will happen? Would it be around AI or something else?
I think what I'm start seeing now is like, and what I'm really, really impressed of is the IDEs, sort of like the tools which we use to write code is getting so much better by utilizing the power of the LLM models. This is just amazing. So I think what I would like to see is more specialized tools, and I'm very excited about, is allowing humans to use the knowledge of the different domain when they would or was able in the past. Now I can ask anything about, like chemistry. The problem is that like, I don't know how truthful that is. It will definitely be plausible, but like, I don't know if that's true. And this is, I think, the biggest problem. But nevertheless, I mean, that's the good way to, like to have your imagination explored. And
Well, Arturas, for those getting into data engineering today, in 2025, what advice would you give to help them stay adaptable and focused in the fast moving space like this?
Yeah, so I think with the AI and especially with the tools, it will be less important that you know Snowflake or Databricks or, like any actual tool, where it will be more important understanding the principles, because you could then say like, hey, I need to move data from this API, which is written with the REST. I will be using Python. Then I want the data to be converted into the CSV files or any other format. And then this data needs to be loaded in our data warehouse. And I need to build, like the pipeline like that using Databricks. And that will generate you the code. But you need to be very specific what you want to do. So understanding the principles, not the specific tools, will be very, very important. And not only for the data engineers. I think that will be for every engineering profession, is you need to get back to the basics.
Well, Arturas, one of my favorite questions now, and the last question for this conversation. What is that one hard-learned lesson that you've had in life?
I think one of the things which I learned hard way is that it's sort of also a little bit reflecting to the previous questions, is that there is a balancing act of everything. And early in my career, I was like, I want to have a freedom and I want to sort of have unstructured data, if you like. I want to have to be able to change schema the way how I want. I don't want to be too structured and pushed into anything. And then after the fact, you're realizing that this unstructured approach is actually costing much more on speed, on performance, and other things. And you're like, if only I would push myself into this more constrained world where the structure is there, sort of like get into the speed. And this is what I'm noticing, and that's sort of the life lesson, is that sometimes the short wins now will hurt you down the line. So I think it's much better sometimes take, a hit now, but then be much better down the line in the future.
Yeah, no, I think that was also a great advice for our listeners here. Thank you, everyone, for tuning into Tech Unhinged. Big thanks again to Arturas for sharing such valuable insights with us again. Thank you so much for your time, Arturas. It was lovely having you.
Anytime. Thank you, Rabia. Take care.